After learning all about the IoT device access services, now let's move on to another service provided by the IoT platform, IoT Analytics. As we mentioned, data analysis is very important in the IoT. It can work with other applications to complete many intelligent application scenarios. In the next, we can look at the functions provided by IoT Analytics. First, we need to know why data analysis is required in the IoT. As you can see from the first chart, China has become the world's largest data generator as its ICT strength and the number of netizens continue to increase. In the future, China will be far ahead of the rest of the world. In terms of data generation, as illustrated in the third chart, among the data generated in China, IoT-related data is increasing at the fastest rate. This data will reach 21% of the total by 2025. The main reason for the rapid growth of IoT data is a deepening of infrastructure construction in China. A large number of devices are being deployed in cities, and these IoT devices will be the key for data generation. It will become more and more difficult to obtain useful information from such a large amount of data. Therefore, data analysis is very necessary. It can help us filter out unimportant data and return effective data to provide sufficient computing materials for intelligent computing. As we all know, there are massive amounts of data in the IoT field. What other characteristics does the IoT data have? In addition to its huge data volume, IoT data features low value density, high time sensitivity, and low quality. A large amount of real-time data is involved in the IoT. The value of data gradually decreases with time. In addition, the low value density and the data quality require more data filtering. How can we analyze IoT data based on these characteristics? First, we need to build a virtual model for devices in the physical world and analyze important data through the virtual model. The asset model uses the digital twins technologies, which we have mentioned earlier. After building the asset model, we can manage scenarios in the physical world in real time through the IoT. Second, we need to process time series data in a timely manner, since IoT data features high time sensitivity. When a large number of devices generate data simultaneously, we need to consider how to write data in real time, how to compress data when not all data is valid, and how to efficiently query data. Third, we need to classify data into hot data, warm data, and cold data by time and process them differently. Finally, we need to efficiently clean data because not all data is useful or complete, since some useless data is generated during data collection. Data cleaning can allow us to obtain high-quality data for further analysis. To meet these requirements, we provide IoT analytics on the Huawei Cloud IoT platform. This figure shows the architecture of the service. We can see that a massive amount of data is generated at the edge and by devices or third-party devices. After this data is processed by the IoT analytics service of the IoT platform, you can use a platform's data management, asset models, and 3 optional data analysis methods to analyze data and generate results. The results can be exposed to the AI platform to provide intelligent services, or to the Huawei Cloud services, or third-party applications to maximize the data value. 3 data analysis methods are provided: real-time analysis, time series analysis, and offline analysis. Among these methods, time series data processing is the most important. We will focus on the time series analysis here. A large amount of IoT data is related to time. We obtain key information in the data, such as timestamp, fields that change with time, text, and measurement for analysis. Time series analysis also features high compression ratio, efficient data query, and efficient data writing. Next, I will introduce another service of the IoT platform, IoT Studio. The IoT Studio service enables developers to quickly develop devices and applications on the platform. Some enterprises may require functions different from the common web applications provided by the Huawei Cloud IoT platform, so they can build their own web applications. Some enterprises want to try the IoT but have limited upfront investment. Some enterprises have limited personnel available for software development and are overwhelmed by the long rollout period of IoT services. Huawei Cloud IoT Studio can help these enterprises quickly build IoT web applications. IoT Studio provides multiple components to help developers shorten the development period, thereby shortening the IoT application rollout period and reducing the development costs. The Huawei Cloud IoT platform also provides IoT Edge and global SIM-link services. Let's look at the functions of IoT Edge first. In previous courses, we learned that edge computing is used in industrial IoT gateways and 5G mobile networks. Actually, edge computing is also used in many scenarios in the IoT industry. Developing IoT Edge is an important task of the IoT platform. There are 4 factors driving the development of IoT Edge. First, edge computing provides low latency services. As we mentioned before, low latency services are useful in many IoT services, such as IOV and remote control of industrial high-precision instruments. Then, a large amount of data is generated in the IoT. However, not all data is useful and needs to be uploaded to the platform. In this case, the edge can be used to filter data to reduce network bandwidth. In addition, a large amount of data at the sensing layer is privacy related. The data cannot be uploaded to the platform or the internet. We need to process the data at the edge for privacy purpose. The last factor is local autonomy. Data processing at the edge does not depend on the cloud. Data can be processed offline and can be self-recovered. Due to these factors, it is necessary to develop the IoT Edge. Now, let's take a look at the IoT Edge architecture and functions. As shown in the figure, the IoT Edge is between the sensing layer and the platform layer. IoT Edge can be used to manage the edge side and platform side in a collaborative manner and perform unified deployment and O&M. The edge can connect to other services on the cloud platform. Computing that cannot be performed on the edge side can be processed on the platform side to enrich the application ecosystem. From the figure, we can see that edge computing is used in many scenarios like V2X, smart campus, and smart logistics. Intelligent Edge Fabric, which is IEF, is also used in edge computing. The cloud platform is far away from devices in scenarios where high real-time computing performance is required. Deploying computing in the cloud will cause problems like long network latency, network congestions, and service quality deterioration. However, the local devices lack computing power compared to the cloud. This is where edge computing comes in. By deploying edge nodes near the devices, the computing capabilities of the cloud are extended to the edge nodes. By managing edge nodes, IEF extends cloud applications to the edge nodes and associates edge and cloud data, meeting customer requirements for remote control, data processing, analysis, decision-making, and intelligence of edge computing resources. IEF also provides unified on-cloud O&M capabilities such as device application monitoring and log collection to provide a complete edge computing solution that contains integrated services under edge cloud synergy. Another service provided by the Huawei Cloud IoT platform is Global SIM Link. The service can manage the entire life cycle of SIM cards and supports remote eSIM card provisioning, which allows devices to select the most appropriate network in different regions. This service can also be used to check SIM card status and perform connection diagnosis on the platform. In addition, you can customize automatic processing rules and platform capabilities. By managing SIM cards, you can manage the network status of devices. What I have described above are all for the services provided by the Huawei Cloud IoT platform. Next, I will introduce the characteristics of the platform. The first characteristic is access agnostic. The IoT platform supports different access modes and access from different devices. This creates an open platform. Second, the platform is reliable. It provides reliability from 4 perspectives: system, network, service, and module. Third, security. The Huawei Cloud IoT platform always takes security seriously. To build an open platform, the first thing we need to do is ensure security so that everyone can trust us in connecting devices to our platform. We strengthen the platform security from the 4 layers of the IoT architecture. Fourth, the platform is scalable and flexible. This characteristic is related to cloud technologies. The IoT platform is designed based on cloud technologies, so its resources can be flexibly deployed and expanded. We can flexibly deploy the cloud platform and deploy one or more industries on this platform. The advantage of elastic scaling is that we can deploy the platform as required, just like network slicing in 5G. Last but not least, capability openness. As we mentioned, the purpose of building an open platform is to enable everyone to participate in the construction of the IoT industry. This can shorten the time for building the IoT industry and application development, so that end users can use IoT applications as soon as possible. That's all for the characteristics of the IoT platform. Now, let's make a brief summary. First of all, we introduce the challenges encountered in the IoT industry and the importance of the platform. Then, we moved to the hierarchical architecture and the solutions of the Huawei Cloud IoT platform. Finally, we explained the characteristics of the Huawei Cloud IoT platform. That's all for this course. In the next course, I will use the Huawei Cloud IoT platform to illustrate the development process in detail. Thank you for watching this course. See you next time.